Welcome everybody to day 20, another day of learning. And today we shall be automating infrastructure creation using Terraform and GitHub Actions. In the past few videos or four, we've been dealing with Terraform and learning what Terraform is all about, installing it, creating infrastructure, managing infrastructure. We have looked at outputs and which are the simple variables that we can use to get information from our configuration. We've looked at inputs, and now today we want to automate the question. So we're going to write some Terraform configuration, and after that, and I'll explain everything. And after that, write some configuration for GitHub Action so that when we push our code to GitHub, the infrastructure is created for us automatically. Okay. So yeah, this is something good to learn, and one of the cool steps that I'm excited about for this DevOps project that we are now building. And of course, like this is the flight booking engine I'm building. And like I told you, since day one, we are going to look at the front end, the back end, the DevOps, and also do AI integrations. So let's continue and start. So I just want to make sure a few things are okay, that my other screen on this other end is working and doing fine. So we need to write some configuration, okay? And you don't have to cram this configuration, okay? I've actually been playing a lot with it, trust me. So after this, make sure you also practice and practice. I've been playing a lot with it, going to GitHub, going to Terraform documentation, going to AWS, and I've been reading a lot, trust me, okay? So make sure you also do the same. So let's continue. So what I'm going to do here today is I'm going to create, just like you see us when when we were deploying on AWS, I think that was maybe either week, I don't know, is it week 11 or 10? But somewhere in the playlist, I don't remember exactly. We created a security group. So I'm going to create a security group, okay? And then we add our instance to that security group. So a security group in AWS is simply, think of it as a firewall, okay? A firewall. So let's do that. So I need to, what's this part? Just need to mute this. Okay, so let's continue. I'm looking for something, but it's not visible. I want the chat to be closed so I can monitor who is saying what and at what time. Okay. So yeah, I guess let's continue. Okay. So what are we interested in right now? We're interested in creating another resource. Okay, to create a resource, I shall simply do like this. Okay, use this keyword resource. Say we need a resource. Okay, what resource do we need? This resource is simply an AWS security group. So we put quotes and say AWS security group. So I'll go to this suggestion. And of course, this can also be got from the documentation. Okay. So we are telling Terraform, create for us an AWS security group. I think of a security group as a firewall, okay, a protection against incoming traffic and outgoing traffic. Where a security group is simply a set of rules or a firewall that you set for traffic that is coming inside your your network in AWS and traffic that is leaving. So the incoming traffic, they call it inbound rules, and the outgoing traffic, they call it outbound rules. So this security group is going to be called, they can call it app server, app underscore app server security group, like that. Okay, I think AI is kind of remembering what I was doing earlier. I hope it does so that I'm fast. So it's going to be app server SG for security group, and you can just specify that the name, okay, is of course the same. Shall say the name will be equals to the app dash server dash security group. Okay. What else do we need? We need the description. This is just a simple human readable description that we can put. We can say this one will be equals to, and say allow inbound traffic on port 80. Okay. So to do that, we shall need the security group to be part of a VPC. Okay. A virtual private cloud. Okay. And this virtual private cloud, we created it actually up here. It's in this module VPC. So a module is simply a reusable piece, okay, in Terraform. And what we are using is a module from Terraform. You see the source? The source is saying Terraform, AWS, modules, VPC, AWS, okay? So we are reusing a Terraform module, which gives us a VPC. So a VPC is simply a network, okay? Think about your isolated network on AWS or in the cloud. That's what a VPC is. And here we have the version of the VPC. The name of the VPC is Airbound Ventures, okay? Then we have the allocated IP block, okay? And then we have uh, this, what is it called? This AZS is something that actually used to, can I say, confuse me a lot, okay? But it simply says, when you say AZS having these three values, it simply says spread the availability, spread across 3 availability zones, okay, for reliability, okay? Then you have the private subnets. So the private subnets are simply networks with no internet access, okay? Private meaning they can access, they have access, no access to internet, okay? That's why they are private. And for the public ones, they are networks with internet access, okay? And then we have here this setting says enable DNS host names, which simply means give the EC2 servers DNS names, okay? As simple as that. So we need to attach our firewall to this security group, okay? The firewall, I mean to this VPC, and the VPC is a network. So security group, which is a firewall for our VPC network. So we need to link these two. To link these two, I'll come here and I say VPC underscore ID, okay, will be equals to module. So we refer to this module here. I can copy and paste, okay, dot this VPC, okay, dot, not dot, but dot, I think underscore ID, okay, like this. Modi.vpc.vpc underscore ID. This is the correct thing, okay? So if you now, and if you've not understood what I've been telling you, we need the security group, which is simply a firewall for our network, which is the VPC. So we have linked the firewall to our network using the VPC ID. I hope that makes sense. Let me just check the chat to make sure all is good. So make sure you learn all these things one step at a time and you get to understand them. Okay. So now to now define the roles of the incoming request, okay, we use what is called Ingress. Okay. So if you hear DevOps engineers talking about Ingress, okay, you think about Ingress simply means the right to enter, okay, the right to enter. So which means we shall be defining rules for what is coming into our network. Then the opposite is ingress. Okay, ingress is the opposite of outgoing traffic, the right to leave. Okay, but what we are concerned about here right now is the right to enter our network. So I'm going to configure the ingress. Okay, the ingress rules. So we shall say we are expecting, okay, traffic from port 80. Okay, say from port equals to 80. Now, what is port 80? Okay, port 80 is the default port for HTTP, okay, on the internet. And then it will be connected to underscore port equals to 80. Okay, why to port 80? If you go to our backend and then we go to Docker compose.yaml, okay, you'll see that our FastAPI app is running on port 80. Okay, that's the reason I'm doing that, running on port 80. So external world on port 80 via HTTP to port 80 internally, okay? And then what protocol? Of course, it will be the TCP, okay? This is the protocol for the internet, TCP protocol. And then the CI dr underscore blocks for this one, okay, will be to allow traffic from anywhere on the internet. So to do that, we can simply say 0.0.0. Actually, I did this earlier on. I wish I had just maybe kept it somewhere and copied it. Actually, I think I have a copy somewhere, but can't seem to get it. I'll look for it in case maybe we get stuck or something. 0. So I think they're about 4 zeros. 0/0. Okay. So the same value we put in AWS. Actually, and actually this one here has to be a string like so. So just to review this, okay, we have a resource. We're creating a resource. Resource is a security group. An AWS security group is simply, okay, is simply, what can I call it? A firewall, okay, for a security group. Oh my God, I think I'm tired. Did I just say firewall for security group? That's wrong. A security group in AWS is simply a firewall for a network, and VPC is the network. We have connected the firewall to the VPC using the VPC ID by saying module, okay, referring to this one, module up there, .vpc referring to this. Then this will give us we can now say .vpc ID to refer to the VPC ID, okay? Then after that, we specified the ingress. Ingress refers to the right to come in, okay? So the right to come in, we're saying from only port 80, okay, to port 80 internally on our machine, and the protocol should be TCP, and we're saying allow from anywhere on the internet. As simple as that. But there's one more thing we need to actually do, okay? We need to come here, okay, to our instance, so that our instance uses this security group, okay? So I'll change, instead of using the security group from the default security group ID from the VPC, I'll remove all this, okay? And then say use AWS security group. I'll copy this name, okay? And paste it here, okay? Dot, okay? Now we need to give the name of the security group, which is app server SG, where their paste, okay? Dot ID, okay? So VPC security groups for our AWS machine is this one here, which we've just created down here. Then after that, we can say, instead of the private subnets, okay, we need to refer to the public subnets, because down here, if you look at down here, we're referring to we have the private subnets and public subnets. And private subnet simply means a network with no internet access. Public subnet means a network with internet access. As simple as that. So I can come here and change private to public, okay? Why public? Because we're going to host our application and we need it to be exposed, okay? So that people in the public, on the internet, can access it. So take note of that. Just check the chat in case there's anything. Fake name saying only 2 people are watching. Keep on going, mate. You will do great one day. Love from India. All the very best. Thank you. Thank you for the encouragement. Yeah. Yeah. So whether 2 people are watching or not, or 1 person, I really don't like mind so much about it. So why I create these live streams actually is to, first of all, for my own learning, okay, to build in public, and yeah, to share what I know and to learn with you all on the internet. Okay. What I've noticed that actually certain people watch the recordings later. Okay. I mean, after like the stream has ended, if you check like after like maybe 5 days, you'll find people have been watching. The playlist actually to this is in the description. If you check the playlist, you'll find that people have been watching them over the past month. Okay. So yeah, it's here. I'm just doing it for my learning. So whether for 1 person, I still keep on going. Okay. All right. So I think we need to test this. Okay. So to test this, I can come here and say Terraform validate. Remember this command, which simply checks that our configuration is okay. So you see we get success. The configuration is valid. Never forget this command. It's a very good command to use. Okay. Now if the configuration is valid, we can choose to say Terraform apply or Terraform plan first. Okay, but I'll just do apply. It will give us the what's supposed to change. Okay. So it's saying no configuration file. So why did Terraform validate tell us that the configuration is valid? Okay. We're actually in the wrong directory. That was weird. Okay. So I'll say cd into the Terraform directory. And that is actually something I forgot to tell you. I put everything concerning Terraform in one directory. And after that, I made these what? And I call them this file like tf.state. Okay, tf.state can have some secrets, so make sure it's added to your git ignore. So you say git ignored all using Terraform. Okay, then this other one here stores your actual modules, plugins, providers, and this is something that Terraform can regenerate. Okay, then when this backup stuff, git ignored it. So basically that's it. So let us do Terraform validate again. Terraform validate and wait. So you see configuration is valid. Now we can say Terraform apply. So it's reading. Okay. So you see the thing that are going to happen. Okay. All this is going to happen. If I expand this to the top, I want you to see everything. So you see an instance will be created. Okay. Then you shall have the security group created. You shall have the SCL. Okay. We shall have the route table created for us automatically. Okay. Pretty interesting. We shall also have the security group. We are seeing the internet gateway created. We shall have the public internet gateway. We shall have the route table. Okay. Yeah, so a number of things we did for us. Okay. So, but now I'm not going to confirm yes because I want this to happen automatically for us. Okay, via GitHub action. So I'm going to clear the screen. Okay, and now let's write a GitHub action that will create this for us. Okay, so you must be asking yourself, what is a GitHub action? Okay, so GitHub actions are simply events, okay, that run on GitHub and run a number of processes on our behalf. Okay, that is simply what GitHub actions are all about. And how it works is that GitHub creates what is called a workflow. Okay, so GitHub uses workflows, and these workflows are simply processes. Okay, that run a set of steps. Okay, and this set of steps are called jobs. Okay, so to create these processes, okay, that is going to run everything for us automatically on GitHub, we need to create what they call a workflow file. We define all these processes in what is called a workflow file. So GitHub Actions workflow simply will simply automate Terraform for us so that we don't have to run commands manually. So to create this workflow, we have to follow a particular syntax. Okay. So in the root, okay, in the root of this directory, okay, of our project, I'll create a directory called .github, okay, like that. After .github, inside it, okay, and again, sorry, my light has gone out, so you may not be able to see my face. So just notice that, but yeah, the internet won't break. We can continue. So call it .github. Then after that, create another directory inside here called workflows. Okay. And simply a workflow is simply a process, okay, that automates for you whatever you want to automate, okay, on GitHub on a machine. And then inside here, this directory, we can create a file I'm gonna call it Terraform .yam. So they are all YAML files. Okay, they are all YAML files, and you can see it is showing red. Okay, I need to put something inside it. Okay, so we're going to create what is called a job. Okay, so a job is simply a collection of steps, and these steps simply run on GitHub and they do the automation for you. But we have to give this workflow a name. Okay, so I can give it a name and say this is, I can say name full colon space and put it in quotes and say this is going to be Terraform CI CD. Okay, you can just keep it simple like that. Now I'm wondering why it is giving me this this red squiggly line. Okay, it's saying required property is missing on. All right, it's okay. We're going to go on and write it. Okay, so this is the name of the workflow. Okay, and the name of a workflow is simply, I'm seeing notifications. So I'll keep repeating. A workflow is simply an automated process you define in your repository using GitHub Actions. An automated process you define in your repository. Okay, where does it live? It lives in your repository under .github/workflows. So .github is a directory or folder which starts with a dot. Inside it, create another folder or directory called workflows. Then inside you can create now your actual file. Okay, so these files can be named anything. Okay, but give it a name that makes sense. But they are YAML files. How are they YAML files? You see that they extend with their extension is that YAML. Okay, or you can actually use YAML. Okay, but I'll use YML, as simple as that. So what does a workflow contain? Okay, simply some theory before we continue. A workflow is made up of events. Okay, a workflow is also, let me just do this. So a workflow is made up of events. That's the first thing. A workflow is made up of jobs. Excuse me. A workflow is also made up of steps. A workflow is made up of actions. Okay, so this file workflows live in .github underscore workflow. Then you create your workflow file, which is a YAML file. Then this workflow file has a name and has a number of events, jobs, steps, and actions. What are events? An event is what triggers. Okay, is what triggers the workflow. Okay, for example, what could be an event like a push? Okay, when you push to GitHub. Okay, when, for example, you do a pull request like AI is suggesting. Okay, a pull request, okay, can also is also an event. Okay, when you maybe do a release. Okay, among others. Okay, what is a job? A job is simply a collection of steps. Okay, like you say AI is suggesting. A job is simply a collection of steps. Okay, and these steps run on a virtual machine. Okay, not virtual environment, but virtual machine. Okay, and I'm going to show you in a moment how to provision this virtual machine. Okay, now after that, what are steps? Okay, now I told you a job is a collection of steps. Okay, when you talk about steps are simply individual tasks which make up a job. Okay, these are individual tasks which if I can type this correctly, individual tasks which make up the job. As simple as that. Okay, for example, it could be a job could be, for example, a step could be like maybe install. Okay, install something, maybe install Python. Okay, maybe run a test. Okay, in our case, install Terraform, etc. Then what is an action? An action is a reusable a reusable piece, a piece of code, as simple as that. Okay, and these are things which are actually like rebuilt by GitHub or other people on the internet, or what we can create by ourselves. Okay, that is simply what a job is. Okay, and these reusable pieces of code are used in your steps. So let's go on and see each of them in step by step. So take note of this. Okay, what a job is, what an event, what a step, what an action is. So let's now create the event. Okay, so to create an event, you'll say, I'll remove all this. Okay, and I'll say on. Okay, so you see like AI is suggesting, I'll say on. Okay, on, then you put the event name. I need to scroll this. On push. Okay, when we push something, okay, to which branch? Okay, then so the event is push. Okay, so to show this push, what can I call it? This push event, okay? It has to be under the on clause, okay? This on clause. So on is how you show, or where is under on is where you define the event, okay? For example, push, okay? So you say on push, okay? When we push something to our code or to the repository, something has to happen, okay? But also you have to specify the branch, okay? So I'll say the branches in our case, we have like main, like AI is suggesting, okay? So in your case, it could be main, in your case, it could be maybe dev, okay? Yours could be, I don't know, whatever you call it, maybe release, it could be fix, okay? But in my case, I have main. Like you can see in VS Code here, I'm only having main, okay? So after that, okay, we can now create the collection of steps. You remember what I call the collection of steps? Okay, and you can see that AI is suggesting the collection of steps is what is called jobs. Okay, we can now specify the jobs here. Okay, take note of this. A workflow lives in a file. A workflow is living in a file called Terraform. A workflow is simply, who can remember? An automated process defined in our repository. Okay, and this process will be automated when we push to our main branch. Okay, and now when we push code to our main branch, we need a number of things to happen. Okay, or a number of steps to be done. The first step, okay, is before even you define your step, you need to define the machine on which your everything is going to be executed. Okay, so I'm going to give this job a name. This job is going to be called deploy, let me call it deploy infrastructure. If I can step infrastructure like that, deploy infrastructure, and then I'll come back. Okay, so you see AI is suggesting a lot of things. Okay, deploy infrastructure, the name of the job, and I'll say it runs. Okay, runs on underscore Ubuntu. Okay, I can go with Ubuntu latest, but this is not a best practice. Okay, it is better you specify the exact version of Ubuntu. Never forget that. Okay, never forget that. Specify the exact version of Ubuntu. But I'll leave Ubuntu latest. That's the one. So it will pick for us the latest version of Ubuntu. So we shall have a Linux virtual machine that GitHub is going to give us, okay? And deploy infrastructure is the name of the job. So I told you a job is simply a collection of steps, okay? So now in GitHub Actions, you can now specify the steps, okay? You can say steps. Let me see the chart. Okay, we can now say steps, okay? Steps, then we go full colon, okay? Then the steps, so a step simply has a name and what is going to happen, okay? A name and what is going to happen. So that's what we're going to do going forward, okay? So the first step, you can call it checkout code. I'll say dash name, can say checkout, okay, checkout repository is also okay. Can I just say checkout code, okay? And then here we can now we can now say this one uses, okay. Now this is an action I told you about. The actions which exist, okay, on what can I call it, on GitHub, okay. I told an action is simply a reusable piece of code, okay. So there are pieces of code which have been created, okay. So for example, if I say actions, okay, slash checkout 3, okay, I can even I can use checkout 2. So what I'm doing is simply a piece of code which is going to download our repo, okay, into the virtual machine so that Terraform can access it. So this action here, checkout at v2, which is simply a piece of code, okay, created for us that GitHub will get and knows that it exists. It will be used to download our repository, okay, and clone it on this virtual machine, okay, so that Terraform can access it. So after we have checked out our code, we have got our code, okay, on this virtual machine. The next thing we now need to do is to configure AWS, okay. So I'll come here, create another step, okay. Say dash name, okay. Instead of following what AI is saying, I'll say configure AWS credentials. Okay, let me just use uppercase C, credentials, like that. Okay, I don't want to follow what AI is giving me. Maybe I could make a mistake. Let me see, is it correct? Okay, so you can see it's suggesting an action here. Okay, so to use an action, you use the uses. Okay, so when you say uses, you're using something that is reusable, a reusable chunk of code. So I think its suggestion says AWS actions, configure AWS credentials at v1. Okay, I think I can go with that and just explain to you what it's doing. So let me indent this. Supposed to be, let me just indent it like this. Okay, so this is an action. Okay, this is a reusable, can I call it a reusable piece of code? Okay, which has been created for us. Okay, and GitHub action will be GitHub will be smart enough to pick it for us. Okay, and it will use it to log in for us into AWS. But to log in, we need the AWS access ID and we need the AWS access key, okay, which is going to come from our environment variables. We cannot hard code it here, okay. Neither can we hard code it inside here, okay. Even the AWS region, this is something we can also put in an environment variable. But we're not using US East 2. We're actually using, we're not using US East 1. We're using US East 2. If I go to Terraform, Terraform main.tf, if I go at the top, you see it says the region is US East 2. Okay. So this is in Ohio. So if I go back to here, I'm going to change this 1 to 2. Okay. That is why it is good to understand what you're doing so that you can always edit, okay, what AI gives you. So where do we put these secrets? On GitHub, okay? Now let me show you how to do that. So I'm going to go to GitHub and you can see on AWS we have nothing yet. So let me go to github.com and then I'm going to look for this site, the project. I'll go to Airbound Ventures. Then, what's this? Then I'll go to settings. Okay. After settings, go to secrets and variables. Let me expand this so that you can see. Then actions. So this is the secrets and variables for actions. So you have environment secrets and you have repository secrets. Okay. I decided to choose a repository secret. Okay. Remember here, there's what they call secrets and variables. Variables can be seen, they're just plain text. Okay. But secrets are hidden. Okay. So make sure you choose secrets and not variables. Variables, plain text. Secrets will be hidden. Okay. And environment secrets are secrets that belong to a particular environment, maybe like develop, stage, okay? and then repository secrets are shared. Okay, so you see earlier on I was testing and playing around with this. Okay, I created an AWS access key. Okay, and its value. So to do, you simply you click on this. Okay, then I can put here, you can say maybe AWS region. Okay, then I can pick from my infrastructure. Okay, this. Okay, come here and I say US East 2, the value. Then I say add secret. Okay, but I did it's not a secret. So I can save it as a variable, but it does not hurt. But I wanted to show you. So you see I have AWS region here. Okay, and AWS access key ID and AWS secret access key. So do not share these two, the access key ID and the secret access key. They are private. Okay, very, very private. So I can come here and do this and say $sign. Okay, $sign, those two brackets. Okay, then close. I can say AI is trying to suggest. They can say secrets. Okay, type secrets dot AWS underscore region. Okay, so you see AI is being smart enough to suggest for me. Okay, so secrets is the variable that will be injected for you into this file by GitHub. Okay, so you won't have to overthink it. So yeah, very, very, very important, my friends. Okay, and you can see it is very simple. Okay, we have a name of a step. Okay, and an action. To use an action, you say uses. And actions, you can either use an action which exists or an action which you can create by yourself. Okay, so checkout is a pre-built action. AWS actions configure AWS credentials at V1 is also an action. Okay, but it has been created for us. We're just reusing it. Someone pre-built it for us, and now we are using it. Okay, so the first one, like I said, simply downloads your code or checks out your code to the Ubuntu machine. Okay, then this one simply helps us to log in to AWS. But to log in, you need the access key ID and the secret access key. As simple as that. AWS region, you can hard code it. Okay, or you can also pick it from your environment variable, like I've done. All right, so let's now continue. Okay, let us continue. So after we have now logged in, now we can set up Terraform. Okay, so the next step will be setting up Terraform. So to set up Terraform, I can come here and say, so you see AI is suggesting. Okay, I'll follow it. I'll say the name of the next step will be set up Terraform. Okay, then go to the next step. Okay, and I can go by what they are saying. Okay, we're going to use an action. Okay, and this action, again, like I've told you, to use an action, you say uses. Okay, this action is called HashiCorp. Remember HashiCorp. Okay, so HashiCorp has created for us some pieces of code which can be reusable. These pieces of code are called actions in GitHub workflow. Okay, so this action called setup Terraform at V1 is a reusable piece of code created for us by HashiCorp. Okay, and will help us to set up Terraform. What does setup Terraform mean? It will install Terraform in the machine, in this machine here. Okay, does that make sense? This action here, or this piece of code, which we have not created, but we are reusing it, will install Terraform on this machine. Okay, so take note of that. But like I've told you, it is wise to specify the actual version of Ubuntu to use. Then I'll come here, and now we can now go to the next step. Okay, I'll not say anything like with, I'll just say name. Okay, so you can see what it's already suggesting. Okay, I can now go with what it's saying, Terraform init. Okay, we can now do Terraform init. So instead of doing it on our machine, okay, and coming here and say maybe Terraform init, okay, we don't need to do that. Okay, let me cancel that. Okay, we now do it on GitHub. In other words, the GitHub action will do it for us. Okay, and the command to run. So run is when you use run when you want to run a command. Okay, you shall use a command called Terraform init. Okay, and what does Terraform init do, it prepares Terraform and downloads all the providers and modules that we need. Okay. Now, but we want to tell Terraform, okay, to run inside the Terraform folder of our repo. So to do that, I'll say Terraform space minus CHDIR equals to Terraform. Okay. So because we have checked out our code on this first step, okay, Terraform will find a directory called Terraform. Okay. So it should run Terraform init in a directory called Terraform. Remember, we have a directory called Terraform here. Okay. So make sure you do the same in case you have a directory called Terraform. Okay. So it will move into this directory and run Terraform init inside that directory. Okay. I hope that makes sense. Okay. Now, after that, we can now go to the next step. Okay. After you've initialized Terraform, all the modules have been downloaded. Okay. All the providers and modules have been downloaded. The next step is to, of course, AI is saying Terraform apply, but I would prefer Terraform validate first. Okay. So I'll say name, full colon, and I'll say, instead of Terraform apply, I'll say Terraform validate. Okay. So we need to validate first. Okay. It's a wise thing to do. Okay. So I can go to the next step. And yeah, we can take their suggestion. Okay. And just indent here and say, yeah, so Terraform validate. But again, it will run Terraform validate in a folder called Terraform in our repo. Okay. In our working directories. Okay, so you can see that chdr is actually a very good command, one option to pass to Terraform. And Terraform simply validates if our Terraform code is correct, just like here. We can run it, and we can run it here. If I show you Terraform validate, okay, you see configuration is valid. So we just need to do it. Okay, after that, next step, okay, we can now do Terraform plan. Okay, can say Terraform plan. So you know what Terraform plan does, like we studied, it helps you to determine to see if things are okay. Okay, if it shows you what is actually going to happen on your infrastructure. Okay, Terraform validate checks if the configuration is okay, but plan gives you an outlay, okay, of what is going to happen to infrastructure, so that you see, is it okay, is it not okay? If it's not okay, then you don't do anything. Okay, in fact, I can show you here on my laptop right now. I can say, if I say Terraform plan and hit enter, so you see it's reading, okay, and you see it's giving us a plan. Okay, this is what is going to happen. So if you revise this and you see that, okay, no, I don't want this, okay, this subnet to be public, then you can now make changes to your configuration. Okay, that's the advantage of Terraform plan. So now we need to for this name, for this step of Terraform plan, we need to also give it a command. Okay, we shall say run. Okay, so by now you can already guess. Okay, I'll accept the AI suggestion. Okay, to run Terraform plan in a directory called Terraform. How does it know about a directory called Terraform? Using this option called CHDIR. Okay, so CHIDR equals to Terraform says simply run Terraform plan in the directory called Terraform, which is this one here. Okay. Now after that, okay, we need finally now Terraform apply. Okay. But before applying Terraform, okay, I want our output to be saved somewhere. If you look at my terminal here, okay, look at this message here. It says you did not use the minus out option to save this plan. So Terraform can't guarantee to take exactly these actions if you run Terraform apply now. Okay, so we need to use it here. Okay, so to use it, I'll say plan space minus out. Okay, and we can say equals to, I'll check the name they're suggesting, TF plan. Okay, so the output, okay, we shall save the plan. Okay, so out says save the plan, okay, in a file called TF plan. Okay, as simple as that. Or simply save the plan in a file. So after we have saved the plan in the file, okay, we can now run Terraform apply. Okay. So I'll go to the next line. See, they're saying if github.ref. I won't do that. Okay. I'll keep it simple and come here and say now we want to run, okay, the same command. Okay. You can say Terraform, okay, Terraform apply, okay. But of course, you know what we want to do. We want it to be in the directory chdr equals to Terraform. So I've explained this again and again. It's chdr equals Terraform simply tells Terraform to run Terraform apply in the Terraform directory. And then after that, you can say minus auto approve, okay? Auto approve, and we tell it to use the TF plan, okay? So auto approve simply says skip are you sure question, okay? Which are you sure question is that? I'll come here, clear my screen just to show if I say Terraform apply, okay? Let's run and I show you that question, just in case you've not seen it and this is your first time seeing it, okay? Are you seeing this question? Do you want to perform these actions? Enter a value. Only yes will be accepted to prove. So, okay, we cannot do that, okay, on GitHub Actions. So we need it to automatically approve, okay, and then we want it to use the saved plan, okay, from earlier, from this Terraform plan step, okay, as simple as that. Is there anything which I'm missing? I'm looking at my notes to make sure I've not missed anything. Okay. So yeah, so the whole summary is that this workflow, okay. And again, I've told you a workflow is simply a process which runs on GitHub to automate things for us. Okay. Workflows live in a directory called .github. Then inside .github, put another directory called workflows. Okay. Then there you can give your workflow, okay, any name, okay, but it has to be a .yaml file. So look at the extension .yml, okay. So this workflow has a name, which is this one here, and it's also made up of an event, okay. An event is something which causes things to happen on your on GitHub Actions, okay. To create an event, use on. An example of an event is like when you push the particular branch. In our case, it is going to be the main branch, okay? Or it could be, for example, a pull request or a release, okay? And after that, we have what we call jobs, okay? A job is simply a sequence of steps, okay, to happen. And this sequence of steps must happen on a machine, a virtual machine, which GitHub will give us, okay? So this virtual machine is specified using runs on, okay? So we shall use the latest version of Ubuntu, okay? But of course, make sure in maybe like in production, you specify the exact version of Ubuntu to run on. And something I forgot to tell you that this machine here is what is called a runner, okay? So you can use existing runners or you can use your own runners. For example, maybe in case of security, in case security is like an issue, okay? Make sure you create your own runner, okay? Maybe I can show you later in future how to do that. Summit or Summit Machanda says, hi Nehe, are we forgetting the step to log in to Terraform registry? Thank you for the question. So if for this case, we don't need to log into the Terraform registry, okay? We won't need to log into Terraform registry, okay? Tell me, why do you think we need to log in? Okay, so let me continue. So, and this, like I said, a job is simply a series of steps, okay? And in our case, we have one job, which will be to deploy infrastructure, okay? We need to deploy infrastructure. And to deploy this infrastructure, we use the name of the job, okay? Like I told, the job is simply a collection of steps, okay? Which I defined here. And these steps will run on what is called a runner, okay? To specify a runner, you say runs on, then the name of the runner. So Ubuntu latest will be given to us, okay? By GitHub Actions. But in the real world, ensure that you use an actual version. And I'm actually going to change this to an actual version. Then the steps to happen, okay? We have the first step called checking out code, which uses an action, okay? An action is simply a piece of code created by another developer, which you can reuse. What does this action do? This action simply pulls our code and clones it on this machine, okay? The next step is configure AWS credentials, which also uses an action, okay, which you simply logs in into AWS using our AWS Access ID and the secret key, okay. And because they're secrets, I access them from GitHub, okay, using secrets dot the secret name, secrets dot the secret name. Where do these secrets live? On GitHub, okay. So you go to your project settings, okay, go to secrets and variables, then actions, okay. Then ensure you choose secrets, then you add your secret. So your secret can either be a repository secret, meaning it is available to the whole repository, or it can be an environment secret. Environment secret means it is for a particular environment. For example, you can create an environment like for development, for staging, for production, for QA, and so on and so forth. Summit Machenda says, where do we save the Terraform state file? All right, so I'm going to show you. If you look at the Terraform, my setup here locally, okay, I have not committed my Terraform state file to GitHub, okay, to version control because it has secrets, okay. So when Terraform init, okay, it runs, okay, that and all these Terraform commands run, okay, this state file will be recreated for us automatically on this Ubuntu machine, okay. And also this file here, .terraform, okay, which has all our modules and providers, okay. I've also not committed it to version control, so it won't be there on GitHub, but Terraform will recreate it. So the state file, okay, this state file will be recreated on this Ubuntu virtual machine, okay. Sami, does that make sense to you? Okay, and we also like I've told you, we don't have to register into the Terraform registry and get whatever we want. Why? Because I using this action here called HashiCorp setup Terraform. Okay, this one will download Terraform for us. Okay, it will says go to sub, but sir, it should be on either of AWS S3. Yeah, using S3 is not bad. So what is going to happen is this, okay? I am later on, if for example, like I'm working in a team, okay, I'm going to use the what is called the HCP, okay, the Terraform HCP, which we looked at in the previous tutorial, Terraform HCP, okay, that we looked at, okay. So I'll add a provider for it, okay, so that my state can be shared with other developers, okay, online, okay. And I won't use S3, okay. I'll use Terraform. Actually, if you look at in the previous tutorial, we looked at how to use Terraform HCP and how to make sure your state is shared with others, okay. And also taking that we have this file, okay. I think this terraform.log, okay. Terraform.log locks our providers and modules, okay. So other developers probably want to see it if they're working with me on the team. The Terraform log will help them, okay. Does that make sense? So HCP Cloud will handle for us the collaboration and all that stuff. We won't worry about the state. Okay, so for that, we now do Terraform init, okay, then we validate, okay, then we plan, then we apply, okay. Something says I've seen and the tutorial, that's why I ask why we're not logged in into Terraform registry. Oh yeah, no need for that. So that Terraform registry only helps us when we want to collaborate. So let's try, okay, let's try and see what's working, what's failing. Thank you for those questions. They made me actually to think. So now I can say git status just to be sure what I'm supposed to push is okay. I need to move out of this directory. Git status. Okay, so we have the workflow, git ignore, the log, main, outputs, Terraform, variables. We've modified. Okay, yeah, this is okay. So I can git add, git commit -m, say add Terraform, add infrastructure via Terraform and GitHub Action workflow. Ideally, this should be separate commits. GitHub Action workflow. Okay. Okay. Actually, ideally, in the end, like you're saying, I'm going step by step. At some point, we should have like tests being happening and so on and so forth. Okay. And now I can do a git push. Okay. I can do a git push. Says some referee rejected. Oh yeah, actually, I remember because I've been playing around with stuff. Okay. Says rejected because the tip of your branch. Let me just force. Okay. Since I'm the only one working on this repo. So that has been forced. Let's go to GitHub. Refresh. I've lost something, a thought of something. If you go to actions, okay. Are you seeing this? It is now working. Okay. See Terraform.yaml. See deploy infra. If I open it, okay. This is the name of the job. So you see things are working. Okay. Check out code passed. Configure AWS has passed. Set up Terraform has passed. Terraform init. Okay. See this message Terraform has been successfully initialized. That one has worked. Okay. Terraform validate. Okay. So success configuration is valid. This one work. Terraform plan. Okay. Let us see Terraform plan. Okay. This is ideally what you would get. Okay. So this is okay. It has also passed. As long as you see that tick, okay, you know it has passed. Okay. Then we go to Terraform apply. Terraform apply was running, but it has also now just worked. You see, post configure, the job is clean, everything is okay. Okay. So if I go back to AWS, okay, if I come here to AWS, you see, now I'm going to refresh. Ideally, we had no instances before. Okay. So if I refresh, we should see one. So you see how easy it is. Okay. So look at the status check. Okay. Let me magnify this. Says initializing. Okay. Without us having to come here manually. Okay. So every time I do a git push, life will happen for us easily. Okay. So let me now give you a clear the future. What's going to happen? Okay. On top of this, next thing what we're going to do is this. We are going to make sure that after the infrastructure has been created, okay, we now what I need to do is to now log in into this machine. Okay. After logging into the machine, I install Docker. I install Docker Compose. Then I clone the repo and run the project. Okay. So all this should happen automatically, creating the infrastructure and deploying the application. Okay. But in fact, before this, I think before this, even up here, we can have a step of running like tests. Okay. I just left it because we don't have unit tests. Okay. But it's something we shall need to do. So the next video should be about now automatically logging into our machine, which we have created, clone the code, install Docker Compose, and set it up. Okay. And yeah, so like I've told you, this is the stage where I am going to be building things piece by piece, learning and growing. So I'm going to show you, where is it? This, okay? Are you seeing this? Let me refresh again. It's still initializing, but if I open it, oh, but look at it, it is running, okay? It says initialize, but let me open it, okay? Just to make sure we look at the inbound roles, okay? So if I scroll, are you seeing the subnet ID? VPC ID, okay? Instance type is t3.micro. Do you see this? This is a free tier, what we chose, okay? What else can I show you? If you go to security, okay? And look at security groups, okay? Are you seeing app server SG? That's the name. If you look at the inbound rules, are you seeing the inbound rules? It's port 80, okay? Protocol is SSP, and the source anywhere on the internet, okay? If I click this, okay, of course you can edit if you want, okay, but there's no need to do this. I can see when the VPC attached, okay. Yeah, so let me leave this. What else do I want to show you? If you go to networking, okay, you see everything has been set up for us. The IP addresses, okay, the VPC, subnet ID, availability zone, I think. We have US East 2A. What else? Networking interfaces, everything has been set up for us automatically without having to uh, hassle and fight with it. So that's, I hope everybody has understood, okay, what to do, how to, because this is like I told you, this set is going to be about the backend and DevOps heavy, okay, then AI integration. So it's going to be backend DevOps AI integration heavy, okay. Then the front end will come very soon, okay. And the goal for me is to build the MVP while you all see, and then once the MVP is done, other things can come in, okay. So yeah, it's been pretty interesting and I've loved it so far. If you have a question, don't forget to leave it in the comment section. And if you're learning this, share it with people in your network with your friends so that we all learn together. Okay. So yeah, I don't need this to keep running. So you can see when the status check says 3 out of 3 checks passed, all is okay. Okay. I'm simply going to stop this instance. Okay. And yeah, because I don't need it. So you can see it says state stopping. So thank you all. Actually, later I'm going to, after the stop, I'm going to terminate it and delete it. Okay. Because I don't need it for now. Okay. But next step, watch out for the next video where we shall now be trying to, yeah, deploy and finish the CI/CD with Docker and Docker Compose. Yeah, later on we shall do other things like maybe Kubernetes, but yeah, not now. For the MVP, I won't need that. So yeah, thank you all for learning with me today. I hope you've got something, and yeah, this has strengthened my understanding. After this, I'm actually going to go back and revise all this again, check the documentation and so many things. So make sure you also read up, even if you're asking AI, yeah, check the docs and stuff like that. Okay. Have a good one and see you in the next stream.